So welcome to our special webinar. In this webinar, we are going to talk about resolvers. Resolvers are part of QF-Test, which help you to better understand or to influence the view QF-Test has on your application. If you think of your application, you think of probably a window showing up, and in this window there are buttons and there are drop-down boxes, etc. But what you see in fact is some lines and some gray or colorful fields and some letters, and seeing this in your mind, you build up the imagination of having real buttons there to push, or some labels which you associate due to the distance with the buttons or with the drop-down box. But this is your human user view on the user interface of the application. QF-Test is a computer program, and as such has a computer program view on the application. That means, well, it sees in memory the objects which construct your user interface, which are, for example, panels and button objects, etc. And also sees the properties of those objects. So sees the string which is given as ID, sees the string which is given as name, and so on. And based on this, QF-Test tries to identify a component for which to record or replay an event. So when you replay an event on a button, QF-Test scans the user interface for this component using the component information collected beforehand or created in a component node, which is, for example, the name or the associated title. So this is the feature or the extra features or the geometry and so on. And this view of QF-Test on the application works fine for, let's say, 90% of the applications, which adhere to all standards. And then there are your applications, or then there are the 10 applications where you have problems with component recognition. You get a component undefined while in fact it is there and you can see it, just QF-Test doesn't see it, or QF-Test sees it but doesn't see that it's the same component, which it should be, and so on. So now you're here, now you're learning about resolvers, and now you learn how you can influence this handling of QF-Test. So this is our agenda for today. After understanding what a resolver is, we want to look at some of the resolvers which are supported by current QF-Test versions, which is the NameResolver is a very simple one, the FeatureResolver, which has the same complexity as the NameResolver, so also a very simple one, the ExtraFeatureResolver, which is kind of a different approach, but you will see the ItemNameResolver, which is also important for getting names in complex items. So it's kind of a sibling of the NameResolver, but for more complex components. And then we want to take a look on how to register resolvers with different script languages. These resolvers, in fact, are small pieces of code which you execute, which are written in your favorite QF-Test supported script language, which due to historical reasons and for the brevity of, I use Jython today, but you can do the same as in Jython, you can do in Groovy and JavaScript, as all modules supported by QF-Test are equal by QF-Test version 4.2. So if you have a favorite module of QF-Test which you use in your scripts in Jython, and then the company has to switch to JavaScript, well, you're fine because you can convert all your calls and the modules are equally supported in all those languages. I will also briefly show you which other resolvers there are, or some of the other resolvers there are. Plenty of resolvers which you can look up mostly in the manual, and there are some of them which you can't look up because we just use them internally, and then that happens, then you in fact need it and our support team gives you a hint, and then you say, wow, that works with QF-Test, I never thought of it. So resolvers are a really powerful feature. I will present you a method of how to find out information which you probably need when you write the resolvers. And then if there's enough time, I can show you what WebResolvers are, which are a variant of resolvers for very browser communication-based testing and component resolving. Well, let's get started. So resolvers, in fact, as I've said, are scripts, are by QF-Test seen classes, which can influence the view of QF-Test, as I have explained, on the user interface. For this, they contain a method which is dependent on what you want to see. So if it's about the name, they contain a method called getName. And the result of this method then is the name QF-test can use for a given component during record or replay. So if you don't return any value or return null or none from a method, then QF-test knows this method wasn't able to determine any name for the component, so I use the NameResolver, or I use the built-in functionality of QF-test. As I've said, you can implement those in all the script languages. You can even implement them directly in Java by implementing the interfaces as explained in the manual, but I won't get deeper into that by today. So the first resolver, or the first way, like a prototype way of presenting the resolvers to you, is the NameResolver. The name is a very important characteristic of a component. If developers use names properly, they can pretty uniquely identify a component. So there's even a mode called the name overall feature in QF-test, which says, well, doesn't matter what hierarchy of components we have, as soon as the name matches, we have the correct component. So name is like at the heart of component recognition, and getting the setting the name of a component is a good practice to do for developers, but you as testers know often you get applications where there is no name set for a component. And then you say, well, but there is, for example, some title, or there is some hidden feature in this special component which I could use as a name. It is not called name, but it is called unique ID, UUID, or whatever else. How can I teach QF-test to use that as a name? And the NameResolver here is the answer for your question. The NameResolver, in fact, is written in a SUT script where you implement or you write a method which normally is called getName, and which gets the component for which QF-test wants to have a name as the first parameter, and then the name which QF-test proposes as default name, so where the default algorithm of QF-test extracted the name as second parameter. So if you just want to change the name a little bit, says, well, for this year, I want to have not an original name, but a 2019 appended to it all the time. Well, you can use the name directly and return the manipulated strings. But if you don't need the name for whatever reason, you just query the component itself, or you make up the name with a random generator, which is not a good idea, but well, you can do it, then you can leave those parameters out. You just write getName of component or of nothing, because QF-test adapts automatically to the number of parameters you give here in the method when you register your method as a resolver using the resolvers module. And you can register this in the SUT script, so in the system under test, because detecting the component is part of your system under test of the code which is running in your process, and you can register them for all the components. So globally, you can say, well, this is just for this specific table, or you can say, well, for all kinds of, and then you give the class name a dialog, for example. For all kinds of dialogues, you can register this code. And as long as you say, well, register my method as a resolver, this resolver is asked for the specific components for the name. And when you say I want to remove the resolver, then the default mechanism of QF-test works again. So for example, we have the car configurator. Well, I just presented to you in live. We have, the car configurators are famous and a little bit aged example for interacting with the SUT. This is a very easy swing application, but it works the same way for FX. It works the same way for SWT or for web tests, and also as well as also for Windows tests, which are available with our next major version of QF-test. So it started up. Here's our car configurator, and there is this info dialog here, which has a lot of information, but no real functionality, but it's fine for our test today. And when we record this dialog here, I just record a click on it. It's the easiest way. You can see there is no name given here. It would be nice to have the name here. QF-test found out that it's dialog, and we gave it automatically the name dialog info, but there is no name. So let's improve that. And now time for our first resolver. I said resolver is a SUT script. So I insert the node. I say, okay, new control structure and new SUT script. And then in our script, I implement the get name method. So in Json it looks like this: get name, and then I return, let's say this is an info dialog. So I just returned the constant for this time. We will make this more complex a little bit later, just for demonstration purposes. And now I have the method. I have to tell QFTest to use this method as a name resolver. So I say resolvers. And here you see all the methods for registering resolvers. So I can use the add name resolver here. So I register it as a name resolver. I say, well, the get name method is the important part. I want to register this for all classes of the type dialog. And now I have this name here, and the name here is kind of an internal identifier of our resolver. So I say this is a dialog resolver. Okay. I run it. Nothing happened. Well, internally, the resolvers at NameResolver method has been called and your method has been registered. We just can't see it anywhere. I just show you that it's there by writing another Zut script where I write print resolvers.list names. It's an easy way to get all the resolvers you registered. And there it is, the dialog resolver is registered as a resolver with the dialog resolver name. By the way, if I want to remove the resolver afterwards, I use resolvers.remove resolver. And now I need the name again, dialog resolver. When I show the list, it's empty. And the alternative would be to say, okay, I don't want to have any resolver at all anymore. Remove all my resolvers. That will remove the one resolver as well. So what happens? I have registered it, and now I record the click on it again. And here I have now my info dialog name as my script set. Okay, this is great. I have the correct dialog. Let's record the click on the OK button. So to close the dialog, this is great. I have now here the OK button. It's part of the dialog here. That's the info dialog. QFTest with the default mechanism also recorded the info feature and the QFS label feature. Let's just for simplicity remove them for a second. Also the other features like geometry, which QFTest uses to identify the method. And this still works fine. So when I open my dialog and I click OK, it's closed. Unfortunately, when I open another dialog, let's say this one, and I click OK, it is closed too, because for QFTest, the other dialog as well is now a dialog and matches to the description here. It is a dialog, and when I ask my resolver, give me the name of this dialog, it returns info dialog, even if this is the vehicles dialog and not the info dialog. So we need some improvement here. We need, in fact, use real information from the component to get the correct name here. And QFTest in this current version already has found this for the label. We use this as well for the name. There is a title of a dialog, and I want to use the title in the resolver script. So I gave it a name to easily find it. So here I need somehow the component now, because I want to get some information from the component. And there is some component, I said, which is named getTitle. Print it out so we can see it here in the terminal. And when I now rerun the SUT script, the resolvers at NameResolver method will be called again. And this dialog resolver will be re-registered. And since QFTest already knows that we have an old version of the dialog resolver in use, it removes the old version first, so it implicitly calls remove resolver for the dialog resolver and registers the new one. So I can just execute this and the new one is registered. And when I now say, okay, let's open this, I saw here that the title info is printed out and the edit vehicles before was also printed out. And when I now try to, let's say, click the button, you see 2 times info was printed here again. So QFTest tried 2 times to find out the component for different steps inside QFTest. So this is a good candidate to use for a name. Let's remove the components we already have. And let's say, okay, only if this title is info, then I want to use the name info dialog. And for all other dialogs, we don't care about the name. We cannot get the name here with this resolver. So let's get started. We record, open the vehicles dialog, and OK. And then I open our info dialog, and OK. And I see now there are 2 different dialogs here. The vehicle dialog, which already has some name, so we don't need the resolver for this one, and the info dialog, which now also has the info dialog name, which is great. And here are different steps recorded where I clicked in the menu and I clicked in the dialog and I clicked the OK button in both dialogs. I already said here for the vehicle button, vehicle dialog, I didn't return anything because the default of QFTest then works when you return nothing. Or you can also say, okay, if here, for example, if whatever something happened, then I want to return none to say, okay, I can't decide anymore. By the way, when I now execute this one, I have here a method which does not exist. So there's some typo in your thing. I also could say, okay, maybe I don't know how to write title and I write it the wrong way. And when I now run this, everything seems to be fine because QFTest only executed that part when running the script and didn't execute the method yet. It executes the method as soon as it requires to execute it. So when I now open the dialog here, I see an exception here in the terminal. And this is a fine stuff because not the complete QFTest crashes or the execution steps, but it prints out the error message in the terminal automatically. I don't need any try, catch, try, except construct in my resolver here. I can concentrate on the internal stuff. And since QFTest 42, when you use resolvers, then automatically this try catch is put around it and the error message is printed out here. So let's get back to that. So this is about NameResolver. I explicitly wrote at NameResolver here, but when I name my method getName, like it is explained in the manual, I can use a short form of it. I can simply say add resolver, and then QFTest sees that the method which you use as a resolver is called getName, and this method matches the NameResolver, so automatically QFTest detects that you want to register a NameResolver here. And you don't have to care about the concrete if it's now NameResolver or if it's special NameResolver or whatever else here. You can just use NameResolver. I also said that QFTest provides you a second parameter here, which is the name. In earlier QFTest versions, so before 4.2, there were two different kinds of resolver. One was called the NameResolver and one was called the NameResolver 2. You get 2 parameters. By now, QFTest automatically detects the number of parameters you require for your method here and selects the correct interface type. And if you don't need the name, it's a good style to leave it out because then QFTest not even tries to find a default name for it, but directly calls your resolver. And only if you return none or null, it executes its own algorithm to find out the name for the dialog. So if you return the dialog name here, it's even more efficient than with the usual way. So it's a good way to only include the number of parameters you need here for your resolver for internal optimizations. I said getName here represents the name of it. I also said there are other parts of the component which you can influence, or component description, which you can influence with resolvers. Another one is the feature here, which is kind of the label in this case. And for this, you need the FeatureResolver. And implementing a FeatureResolver here is very easy. You say, I now name my method getFeature, and then I simply return, for example, here the title plus feature. I run this. I might just remove those. So QFTest creates new component information when I click it. And let's set here. It's used info and then minus feature as the feature, and also use this for the QFTest ID. Right, so if you want to say, okay, I have a fixed feature, for example, I can also just return here info feature. This is the easier way. So when I now re-record it, you see that a new dialog info has been created here. Sorry, I forgot the return statement here. So let's do it again. And another dialog has been created here, so another dialog component. And this is quite interesting because it says as long as you register your resolver, the feature here is info feature. And when I now, so here, when I say, okay, this one is, this one is available here, it highlighted it. If I try with that one, it finds this as well because the feature just one part of the probability, but when I re-recorded it, it was created as a new component information here because the feature has changed. You see, QFTest is smart enough to even find the dialog with different features. So here the info feature wouldn't match, but when I say highlight component, it still finds the component because the other things like here, for example, the extra feature for label matches and the geometry matches and so on. So QFTest takes all these features here into account when calculating a probability for the dialog being the dialog in question at the moment. With the ExtraFeatureResolver, you can influence the extra features here. Extra features are a little bit different from the feature because the feature is just a string here, but these are sets of key value pairs. So you can add more features here by giving them a name. QFTest by default names all the extra features recorded with QFS colon and then some specific ID. You can give your extra features any name you want to have, you like. Then there is a string as the value of it. And then there are 3 more properties of extra features. Every extra feature has a state, and the state can be either ignore, should match, or must match. By default, the state is ignore. That means it is not taken into account when calculating the probability of a component, be that the component being component in question for your event. When you have selected must match, then QFTest only uses the component for the event when the extra feature resolver or when the extra feature calculated for the component is the same one as in the component description. And when you have a should match, then it is taken into account with a certain probability. So when I change here, for example, the info to some other stuff, info ... and try to highlight this, it still works, but there is some lower probability for it. If I change it now to must match, it cannot be located anymore because the calculated extra feature for QFS label here is info and not info ... So to influence this, you need an extra feature resolver. And the easiest way is to say, well, I now want to have the extra features. So it's named get extra features. But extra features, as I said, are not just a string, but a set of elements. So we receive the set of elements here as second parameter. and I just print them out for you so you can see what it is. Register the resolver, record some click here, and you see here how often the ExtraFeatureResolver was called. A lot of times you see it as a class of the type ExtraFeatureSet, which contains the information about the key value pairs inside. With this key value pairs, we can do different stuff. We can, for example, say, okay, we're just interested in the one feature, let's say the ExtraFeature QFS label. So we say features.get QFS label. And no, it does nothing. So let's say we want to print this out. And when I now record, I get a lot of information here about the should match label extra feature. You've also seen that the extra feature has a negate flag here, which says, okay, I just want to have this not matching. So kind of must match and not would say, okay, this one is not cannot be found anymore as long as I don't change this to anything else, like today is Monday. This is a great title which does not match, and I can't use that anymore because I have the wrong resolvers registered. So resolvers don't exist anymore. I cannot use those components anymore. I just re-record the component. And yes, because of my ExtraFeatureResolver, now it's not recorded here anymore. Oh, yeah, the curve test ID is kind of weird at the moment. So what can I do in the ExtraFeatureResolver? Well, the first thing which I can do is I can change here existing extra features and their properties. So I can say, for example, the extra feature I have, I want to have it a must match state, for example, the QFS label, or then I have to say, okay, I want to set the state of it. And then my resolvers module has those 3 states as constants here. I say, okay, it must match. And when I now re-record after running my resolver once, I re-record my dialog here, and now the extra feature QFS label has switched to must match. By the way, there's also a regular expression thing here. So if I say, okay, this one is not a string, but I want to match it like all the strings, all the classes in the Java Swing package, I can say, okay, I want to change this to regular expression. Then also the check here is set for regular expression, and then I change this for say, okay, all the classes inside the Java Swing package should be matched, which is great because this is ignored anyway. But it changed nothing here, and highlight it's still found. But I can also say, okay, I want to add new features. So I say feature.add, where I can add some name, let's say example, and the value, which is, let's say, value here. I register this one. I record a new dialog. Now it has found the dialog and reused it because only the extra features changed. There is not the extra feature here. So for this case, I have to create it again. So record it. And now I have here my example extra feature value name with the value exclamation mark. And it is, as I said, in the default ignore state. When I want to have it in another state, just give this as first parameter, I say here, resolvers, and then, for example, should match sorry, wrong position. Here, of course, when I have to edit. Okay, and let's record it. And I have now here the should match state in the extra feature description. I can also say, okay, for sometimes I don't want to have, for example, the QFS label recorded. Then I can also say something like features.remove QFS label. And when I now record this one after executing the script, no. Then the feature won't be recorded anymore with it. So it's not found at the moment. But the idea is clear. Now I explained to you the name resolver, the feature resolver, and the extra feature resolver. And then there are some components in Swing or which QFTest can handle, which do not only have the single name, like for example this table, but which have additional items in it, and the additional items have names. So for example here, when I record a click here on some component here inside, I see that QFTest records a click on the vehicle table itself, but then it doesn't record some click on a column or a cell inside the table, but you can use the extended syntax to say, okay, I want to have the click not on the table in general, which would automatically click in the middle of the table, as you can see by this. Well, by chance it's the same element, but let's say I want to have it on the first element, then I can say, okay, this one, you see the click ran fine. This one should go to add price with an uppercase letter. And then, for example, add the first line, which is $12,300.00. And the dollar is here a sign which can interpret it as a variable. So we have to escape it with another dollar. And then the click goes to the first column, first row and the second column, sorry. But you say, okay, maybe the name here is not very nice. It would be nicer to have something like only click here on 12,300. And for this, we can implement ItemNameResolver. So let's say create a new SUT script. And in this SUT script, name it get item name. We again get the component, which is now the table, so the surrounding table. Then we get information about the item. And then we get the name, which is proposed by QFTest itself. So let's print out the information, just that we know what it is, the item, and then the name, and the component as well. So we get 3 lines. Maybe this is a little bit complicated to find out later, so we print some more information. And then we say, okay, resolvers dot add resolver, price resolver, get item name, and we just want to have it recorded for tables. So I say like this. I run it once. I have a typo here, resolvers. And when I now try to replay this one. Sorry. Is not executed because the vehicle table has already recorded those information. So let's say we want to record it only for this vehicle table, the resolver. Then we can also say, okay, let's just have it for this one component here. Let's say get component. So to demonstrate how you register resolver only for one component. And then it's not used for the other tables, which are in the other slides here. So do something else. So let's register that one, clear the terminal, replay this one. It just doesn't print out the information here. The idea is clear. When I look on the time, I see that time is already running. So I show you already how it looks in the end. I have prepared a suite here with all the examples, which I will send you by tomorrow, so you can see if you have any questions left here, if you have other questions. And there are also some examples and all the slides which I showed to you and more, so you can try to find out the information you're looking for there. Here I have the SUT script, and I already finished the script. I added some more information. Here you see the item is an array with two elements. The first one is the column, the second one is the row. And I can say, okay, I just want to return some information when the item name, when the column is the first one, and then I split it with a dot, and I remove all the commas before, and I remove the $, and I just use this one as the name. So let's execute this one here, the SUT script. And when I now record the click, let's record on a new one here. You see that all the information about dollars and commas and dots are removed, and only the simple 92,000 is written here as the item name. So this is the example of item names, some more complex resolvers. I always wrote JSON scripts here because they are pretty dense. As I said, it's also possible to register those in Groovy and JavaScript. Here, for example, is the Groovy variant of the NameResolver. Since Groovy interprets all the complete script you execute as a class and an object, you have to give the reference to the method in the current class as reference with add_resolver. So this is written like this. This is the current class, so it's the script itself, and then dot add end, and then the name of the method. When you use not add_resolver but the longer variant, QFTest does not have to guess which resolver you want to use, and you can use then also methods without a name, which in Groovy are called closures, and write the resolver in one line here. It is the default first argument of a closure in Groovy, so you can say, okay, the title of the first argument, if this title is info, then return info dialog, in this case info dialog 2, otherwise return null. So we just kind of don't care. This you can use with the NameResolver, and also in JavaScript. It's a good way to provide directly the type of the resolver you want to register, and then you can use it the same way here. So we give it get name here. Get name references this local variable, which has the anonymous function here, which only just the component. And again, because the JavaScript here is executed in the Java virtual machine, we can directly access the component methods get title here to get the title from the swing component inside JavaScript, and then interpret and return a JavaScript string, which is then converted into a JavaScript string for the sake of comparison with the component information. So when to use which resolver? I already presented the NameResolver, which is good to solve problems when you have dynamic names or there are a non-unique name set in your application, so you want to make them unique. So you can use a NameResolver there, or if the QFTest NameResolver is not optimal for your application, you can improve it by using a better algorithm there. the feature resolver, same thing for features. And also, if you're finding out the feature takes too long for your application because you have, let's say, a very complex label structure, and QFTest searches a long time for a good label to use as a feature, you can say, okay, just use an empty string as a feature to skip feature resolution. The extra feature resolver I already presented, where you can also modify the default extra features generated by QFTest. And the ItemNameResolver to improve the textual representation of items. Then there is an ItemResolver itself. So this is used if it's not that clear to QFTest what are items of another component. So for a table, it's already coded in. The cells inside a table are part of the table component. But if you, let's say, have some board on which you can put some boxes with lines in between, and in those boxes, like in a mind map, you write something, and then you want to say, okay, every box is an item of the complete mind map. This is difficult for QFTest because this is a component which you made up yourself, or your development team made it up, and you have to teach QFTest how to make this relationship in between the mind map and the nodes of the mind map. And for this, you can use an item resolver. You can find an example in the documents which I will send to you. And the item value resolver is like the item name resolver, only for the internal value. Then there is a tree table resolver, which you use when you are in Swing and you want to have a table with a tree in front, which is a standard component in other UI libraries like FX or SWT, but which does not exist, unfortunately, in Swing. Having said this, a lot of different implementation of how to make up a tree table in Swing exists and are used in the wild. So probably you have one in your application as well, and you want to teach QFTest that this is in fact a tree table, where you have a table connected with the tree elements on the left side, and then you use the tree table resolver to, well, define the connection between the table component and the tree component, and to say which part of or which item in one component matches the item in the other component. Also, for example, if you have a web test, sometimes the visibility and also the enabled state of a node are made up of non-standard attributes. For example, an enabled result, normally QFTest checks for an enabled CSS property of a component to see if this web component is enabled or not. But maybe your application uses some invisible overlay and then makes the color of the element gray. And QFTest doesn't know about this because it's just in your application like this. But you can teach it with an enabled resolver that in such a situation, the component should not be clickable, for example, anymore. And the same with visibility resolver. Maybe you placed some things about it and QFTest didn't check it correctly because, I don't know, special CSS attributes. Then normally QFTest reduces the numbers of levels in the hierarchy it records and replays, and just records important or just records parents of a component which are important for recognition. But with the interesting parent resolver, you can define which parts of the hierarchy are important and which are less important. ID resolver is like a name resolver for HTML elements. And then there's the busy pane or glass pane resolver and the event synchronizer, which you use to help QFTest to wait until it can send the next event. QFTest has a pretty sophisticated syncing algorithm which tries to find out that if the application is still busy or not, or if you can now look for the next component or click on the next button. And sometimes the automatically detected glass panes or busy panes do not match the one you have in your application. Maybe have a special spinner or anything like that. And then with a busy pane resolver, you can say, as long as the spinner is visible, my application is busy, so please QFTest don't issue the next event before the spinner is gone. Or even you can implement something which is not based on your user interface. For example, well, let's check the database, and as long as there is some special entry in the database, the application is busy. So you can program this out for the event synchronizer and then check the database if the element is there. And as soon as the element is gone, you say, okay, QFTest, now it's fine. You can issue the next event. You can click the button or whatever else. And you find all the information about the resolvers and how to use them in the manual. When you're going to write your resolvers, sometimes you are not part of or often you're not part of the development team, and you don't know like what are the good methods to use, how to find, for example, the title of an element, and there QFTest is there to help you. When you are in the component recognition mode, you can click an element and then say show methods. And QFTest presents you with some dialog where you have all the methods which you can call on the component to get information from it. Most times it's getters, so there's a little button here where you can say just show me the getters. And then you see, for example, there is something like a get column name to find out the name of the currently clicked column, etc. And this helps you to find out about the names or about the properties of the component in question. And sometimes you want, for example, to use another component which is a parent or a sibling of the parent to define your table or to find your component here. And there is a property which can help you in the options where you can set, I want to record not only intelligently the parents, but all the parents. And when you now record some component like this button here, okay, I have the button already inside the pane, and now it recorded all the panes way down to it. But I can now do something like a count and then say, okay, maybe this one is the important one, and I want to get the first element, the first child of this one. So inside my resolver, I can then say like a component dot get parent dot, and then, for example, here I get also the methods of this panel. Probably I say something like get children and then the first child and then get name. And QFTest is there to help you with exploring your interface and finding out these methods which you might want to call inside your resolvers. Don't forget to reset in the end the hierarchy back to intelligent, because otherwise you get big hierarchies and this doesn't make it easier for you to find out what the concrete and correct component is you want to edit, etc. I promised I explain to you another thing, which are the web resolvers. So they're different from the probably custom web resolvers. Custom web resolvers are in fact normal resolvers controlled by string input. So the normal resolvers which are by default registered from QFTest and where you can only influence their action by providing them specific parameters. These are parts of a special webinar in autumn or in fall, depending on where you live. This, what I want to show you, the web resolvers are classic resolvers which are executed in the browsing context. So I just switch for a moment to a browser and open the standard car config browser application. So this is our example of the same configurator as a web application. And for example, maybe I had implemented a special resolver where I want to record an extra feature about the number of the element this is within the table. So just for a second, execute this and then I show it to you. Here I have the extra feature, extra row info recorded with the name row 1 of 6. So I have written some algorithm which counts the elements, the rows here, and then sees if the element which was clicked is one of those. And well, I show you in the little script here. So I've written a lot of JavaScript here inside my resolver. I said, okay, on the component which I get, of which I want to get the extra feature, I call the cell index method of the corresponding node in the browser DOM. This is to get the index of the column here. Then I want to have the numbers of rows here. I want to have the rows itself because I want to have length, so the numbers of the rows. Then I iterate over the numbers of the rows to see which of them is the row which I want to get. And then if I find the matching element by comparing the current element, so the QF node, which is the current component in an eval.js string, to this one, so the today element of the parent row, then it's matching. Anyway, I just return the string here. And there's a lot of eval.js code, and you have to know for every eval.js code, QFTest has to call the browser and to say, well, let's evaluate this one, and the browser evaluates, and then puts it in a format which can be read by QF-test and sends it back to QF-test. And as you see, I have to talk a lot, so there's a lot of work involved, and this takes some time. So sometimes if you have resolvers written like this, where a lot of eval.js calls are made, it is better to do the resolving directly, completely in the browser, and this is where WebResolvers come in. WebResolvers are pretty similar as resolvers. You see, they are called the same way, just WebResolvers. And then the second parameter is not the method itself, but is a string which contains a JavaScript method, which is then executed inside the browser. So in this case, we have a Groovy script here, which contains a string. And in this string, there's the JavaScript method, which is then executed in the browser and is completely in one JavaScript method, the same code, in fact, just written as JavaScript. And when this is executed, it is just one JavaScript call down to the browser, and it's just one time the communication to the browser and back. So this WebResolvers are for special edge cases, and you can use them to improve performance of QF-test for those special cases. So you also find information about this one in the slides, which I will send to you by tomorrow. And I hope you enjoyed this special webinar. If you have any questions, feel free to write me an email or to write an email to support@QFST to our colleagues. They're happy to answer you all the questions you have. And I hope with this information, you are able to improve the component recognition of QF-test even further and further stabilize your tests. Thank you very much.